to take place. And when we cause that combustion to take place, we can move a piston. Y'all follow me? All right. So we have successfully defined work. And work is right here, number 11. So the net force, is that what I had up here? Oh, no. So mass times acceleration times the displacement equals to 1/2 times the mass times the final velocity in the x direction squared minus 1/2 times the mass times the initial velocity in the x direction squared. So we call the left-hand side change in work. And the right-hand side, we call this the change in kinetic energy. And I should write that out. And kinetic energy is just defined like so. Me like that. Kinetic energy is just 1/2 mass times the velocity squared. So whenever you see this, or whenever we're talking about kinetic energy, we're talking about energy that has what? An object is doing what? The object possesses mass, and the V represents what? So that means that object is doing what? Moving. It has to do with movement. Energy associated with movement. Okay? The units for this is what? What are the units for mass? Kilograms. What are the units for velocity? Per second. And that's meters per second. What velocity is what? Velocity is squared, right? So that means it's meters per second squared. So that's meters squared, second squared. You guys know what that unit is? What is this unit? Yeah, close, but it has a meter squared. You see that one? It's a Newton times a meter. Same thing, it's a joule. So this is also being represented by joules. But it makes sense because we're talking about kinetic energy. If you guys accept the term kinetic energy, is 1/2 mv squared. So we have, this is called the work energy theorem. Work energy theorem. Delta W equaling to delta KE It's called the work energy theorem. Super, super powerful. Super duper. We can talk about energy from mechanics, which is what we're talking about in a sense now, to thermodynamics, which is where the conservation of energy actually, well, this work energy theorem comes from, to quantum mechanics, electricity and magnetism, everything. We can derive all kinds of equations from it. So this is the work energy theorem.